no way that the next actual potential can be triggered. So that period is called absolute refractory period, meaning during this part where it is getting depolarized and repolarized, next actual potential cannot be triggered. So there is a complete block of triggering the next actual potential because the membranes are going through the change here. So the next one will completely disrupt the process, and it is completely denied. Then towards the end of the repolarization, the next actual potential can be triggered because that period is called a relative refractory period. That is towards the end of the refractory period or towards the end of the repolarization. So when the membranes are in this condition, when they are getting repolarized, then the actual potential can be triggered. But during this period here, which is absolute refractory period, no actual potential, the next actual potential cannot be triggered, cannot be sent, cannot be propagated. So actual potentials actually travel differently in unmyelinated versus myelinated axons. So some axons are myelinated with the help of Schwann cells and oligodendrocytes, and other axons are not covered with the myelin sheaths, even though they do have cells, Schwann cells and oligodendrocytes, but they don't have any myelin sheaths present around them. So in unmyelinated axons, the conductance or the conduction of the actual potential are continuous. They are going through the membrane, they are traveling, they are getting propagated from one end to the other one, going through the membrane, which are unmyelinated. So the conduction in those cases is continuous. It is going through the axons in a continuous fashion that I'll show you in the next slide. And that movement of the actual potential when the membranes are getting polarized, depolarized, polarized, depolarized is called the local current, because it is in the form of change of these charges. So it is in the form of a current, which is called a local current. So in unmyelinated axons, the movement, the conduction of the actual potential is continuous, and which is shown here. So this is again an axon, and this is the cell body of this neuron. So it is moving through the membrane in a way where it is getting, this one is getting depolarized. So when it is depolarized, then it moves, it kind of depolarizes the next part of the membrane, which is inside this axon. And then when the actual potential travels from here to here, then from here to here, it is getting other part of the membrane depolarized. And it is the example that is shown to actually to kind of understand this is this dominoes block. So if you have several of those dominoes blocks that are aligned together, and you kind of push one of those, it will actually just knock down all of those that are present after that. So in this case, when this part of the membrane is depolarized, it will depolarize the next part, which is this block, and then this one will depolarize this block, and it will continue to travel like that till all the blocks are knocked down. So it is traveling, and this wave is traveling in the same way this current is traveling through the axons. In case of those axons which are myelinated, the traveling or the conductance of the actual potential is called saltatorial type of conductance. This is called saltatory conduction. So in which case, the actual potential, which is depolarized, goes from node of Ranvier to the next node of Ranvier, because those myelin sheaths make this completely insulated. So it does not allow the conductance to take place through those sheaths which are present on these membranes, which are present on these axons. So the only way for those actual potentials to move will be from the jump from here to here, and from here to here, and from here to here. So this is kind of the jumping effect in which it bypasses this whole area here, which is covered under myelin sheaths. So it is moving from here to here, from here to here, to here, to here. And it travels much faster that way because it does not have to go through the membranes, so it is kind of bypassing and takes much faster path as compared to when those axons are myelinated. Okay. So what are the synapses then? Synapse is a junction between two cells. That junction could be between two neurons, or it could be between a neuron and some target cell or some effector cell, like muscle cells, for example. So this is the site where the actual potential that is present in one cell, that could be again a neuron to the next neuron or neuron to the target cell, could be the muscle cell. So this is the site where the actual potential is passed from one cell to the next cell. And the types of cells that are involved in the synapse is the ending of the first cell and the beginning of the next cell. And that area is this presynaptic part and then the postsynaptic part. Synapse is again, let me go to the next slide. So that part, this is the synapse. So this is the ending of one of the cell, and this is the beginning of the next cell. This will be the ending of the neuron. This is the beginning of the next cell, or the beginning of the next neuron. This whole area is called a synapse, which is shown here with a small gap in between. This is the presynaptic, and this is the postsynaptic membrane. This is the presynaptic terminal, the ending, and this is the beginning of the next one, which is called postsynaptic membrane. There's a lot of activity that goes on here in order for that actual potential to be passed to these cells here. And that is in the form of release of some chemicals or neurotransmitters, and then binding of those neurotransmitters to the receptors present in the postsynaptic membrane, and then opening those channels to cause some of the membranes to, some of the ions to be moved inside the cell. So I'll come back to this slide. Let me go back here. Okay, so the types of cells are the presynaptic cells and the postsynaptic cells. Presynaptic cells are the endings of the first cells, and postsynaptic cells or membranes are the membranes of the next cells that actually carry the signal that comes from the first cell, because they are connected with each other, and the connection helps them to carry signal to the next cells. So there are two types of synapses, electric and chemical. So we'll talk about the electrical synapses when we talk about the circulatory system. Chemical synapses, what is done through the neurons. So the chemical signal that is produced by the cell bodies of the neurons are in the form of chemicals. Those are the neurotransmitters. So in case of neurotransmitters that are released by the axial potentials, axial potentials are the changes of the charges in the membranes of the cells or in the membranes of the axons. So when that signal in the form of electric current arrives at the ends of the neurons in the presynaptic terminals, then presynaptic terminals trigger the neurotransmitters which are present in that area of the presynaptic terminal to be released. So they actually are released in the synaptic cleft, the area between these two membranes, presynaptic terminal and the postsynaptic membrane. So neurotransmitters are released in that area. Neurotransmitters have their own receptors that are present on the postsynaptic membrane side. So when the actual potential arrives in this area where these vesicles of neurotransmitters are stored, so that causes this permeability of calcium. Calcium comes in, calcium triggers the release of these neurotransmitters in this synaptic cleft area. Neurotransmitters bind to their receptors here, and these receptors are sodium gated channels. So neurotransmitter binds to the receptor, and then this channel opens up. When this channel opens up, sodium from the outside goes inside this postsynaptic membrane, which are the cells, and then what happens is when the channel opens, sodium goes inside, when sodium goes inside, what happens? It becomes more positively charged. When it becomes more positively charged in this cell, that means that it becomes more depolarized. So the membrane has become depolarized. And that means that actual potential, that was the changes, depolarization and repolarization in the membranes of this cell got transferred here. And the intermediary there was this neurotransmitter. So neurotransmitter caused to change this electric signal into a chemical signal, and that chemical signal got changed back into electric signal again. So because the membrane inside the cell has become depolarized also. So this is how these neurotransmitters work. Neurotransmitters work by binding to the receptors and causing some changes in the membranes. So when we receive that signal from our brain to move a muscle in our body, when I'm moving my finger, so that the moving of that finger is being caused by my brain. And what brain is doing is, brain is sending that signal from the neuron to this muscle which is present in my finger to move it like this. And that movement is being caused by sending an electric signal from the cell body in my brain, and that cell body is carrying the signal through the axon which is present in my arm, and it is connected all the way to this finger here. So at the end of that axon, there are neurotransmitters that are saved in that area, in which the axon is attached to the muscles of my finger, and that muscle moves. Because when the electric signal that is being sent by my brain arrives in that part of my finger where the ends of presynaptic membrane, presynaptic terminal is attached to the muscle, so that muscle receives the neurotransmitter, which is acetylcholine in case of skeletal muscle. So the skeletal muscle receives the signal in the form of chemical and turns it into a kind of an electric signal again that causes the muscle cells to become depolarized. So the depolarization of the neuron, of the axon, is transferred into the depolarization of my muscle cells. And that's how the muscle cells will move. That's how the muscles move. Because the signal that is being sent by the brain in actual potential is transferred into chemical potential or chemical signal, and then that's what really causes it to do something. Once the neurotransmitters are released, then neurotransmitters are either taken up again by the cells or they are completely degraded. So they could be degraded, and that degradation will remove those neurotransmitters that are present in that area. And in case of acetylcholine, there are some enzymes that are present in this synaptic cleft. So those enzymes break down acetylcholine. This is the enzyme. So it breaks down acetylcholine into its component, which are choline and acetic acid. And after they are broken down, they go back inside the neurons, inside the axons, and then they are reassembled into acetylcholine, and they are stored again in that area. So brain really does lots of different things there. And this is the function of the brain also. So brain cells are making these acetylcholine, which are still kept here in this area, and then when the next actual potential arrives, the same thing will happen to these vesicles that are filled with acetylcholine. So they will be released here, and then after the actual potential is over, then acetylcholine is broken down into its components, and then it is reabsorbed here and repackaged in the form of those vesicles, and it continues to recycle them like that. So it continues to make things happen inside the body. Muscles contract, and glands continue to secrete their hormones in the body. So it is all happening because of the actual potential that is generated by the cells, in this case the cells which are present in our brain, neuronal cells, neurons. Neurons send that signal in the form of an electric current. Electric current, when it is received here in the synapse, that electric current is converted into a chemical signal, which is these acetylcholine and other types of neurotransmitters. Neurotransmitters bind to the receptors on the surface of the cells and then open those channels, and opening of those channels help some of the ions to go inside the cell, so that signal is converted again into an electric signal. That helps to do certain things in the body. So we're going to actually skip the norepinephrine neurotransmitter, but just concentrate on the top one. All right, so that's it for this chapter. So I hope you get something. Well, I'm going to post this video, so if things are not clear, just take a look at it. If things are still not clear, then watch some of the videos on YouTube. If things are still not clear, then we can talk about that actually next time before we start the next chapter.
What will we be doing on Monday? I want